where they're all right, up here, please. Does anybody want me to go over a specific problem that they feel was kind of tricky? And again, all this is done without a calculator. All right, all of it's supposed to be done without a calculator. All right, I'll be giving you calculators later. Anybody? Nobody needs me to do anything. 27. Is this guy right here? How many years are there in 48 months? So listen, what I was trying to tell you by giving you an example is the first part is the same exact answer as the second part. So if you were able to say, okay, there are 4 years in 48 months. If your brain knew that, then what? Then you knew how to do this. Because you just did 48 divided by 12, right? And easily got 4. That's all there is to it, buddy. M divided by 12. That is the answer. That's what I'm trying to tell you. Sometimes when you do algebra, the variables don't make sense at first. But if you give the variable a number, it kind of makes sense of what exactly to do. So that's what I'm hoping you can understand about that. All right. Does anybody else want me to do a couple? Yes. 38. Here we go. This guy right here, right? All right, let's make sure we can do the fractions. Please, I mean it. Everyone's got to be up here. If you got this right, then you're in good shape as far as the fractions go. First thing we have to do is do PEMDAS, right? So we're knocking out the 6 right here and here, correct? So now I have 7/15 minus 1/5. Now I do the division. So division changes to multiplication, and this becomes 1/3. Does everybody agree with that? So then that should have been plus 4/15. Is everybody okay with that? Now, the first thing that came to my mind is like, wow, I know what 7/15 minus 4/15, that's what? 3/15, which is the same as what? 1/5. And 1/5 minus 1/5 is what? If you got 0, you're in pretty good shape with your fractions. All right. If not, and you need some help, you got to let me know. With which one? 29. Thank you very much. All right. Oh, my goodness. I'm so sorry. Yep, I was going too fast. I saw the minus. I can always count on you. Thank you for keeping me honest. That is correct. Start this over. Man, I'm going to have to delete that tape. All right. So 7/15 plus 4/15 is what? 11/15, right? And then I need a common denominator here. Right? So that's going to be 7/15 minus 3/15 plus 4/15. Everybody happy with that? All right. So I end up with what? 8/15. All right. Thank you. Now you can give yourself a check if you got that right. All right. That was totally my fault. All right. Now I'm sorry with that. Thank you, Nora, for always keeping me on task. Go. 29. Let's take a quick look at 29. The difference between two numbers is 9. All right. I like this. All right. The difference between two numbers is 9. All right. Now here's what I want you to do. I want you to tell me the difference between two numbers that are 9. What comes to mind? Shh. Just tell me any two. Give me an example. How much? 15 minus 6 equals 9, right? So if X is the large number, right? How do I find the smaller number? If X is the large number, how do I calculate what this small number would be? So 15 plus 9 is 6. You would do what? Yes. So it would be X what? No, here's what. Listen to what I'm saying now. So I'm trying to figure out what the smaller number is. Do you agree?
Yeah.
I know the larger number is what? Yes. So if I have 15 and I want the smaller number, how do I get the answer 6 from 15? And don't forget, the other number that we're using is 9. Somebody help him. What? X minus 9. Right? That's this.
Oh, yeah.
You see what I'm saying now, right? Now look, I'm the only reason I'm explaining it that way is because that makes sense to me, but I also think that's a very hard problem. But I'm telling you, if you learn to create your own problem like this, and this is what I was trying to get you to see. All right, we know that this is X. I'm trying to find this number, and the only other option I have is what do I do with these two things? You see what I'm saying now, right?
Yeah.
All right, that was a very good question. Thank you for asking. Go.
41.
All right, let's knock out 41. All right, I like that. So let's first do the numerator. What's 2 times y? Yes.
8.
Plus z.
11.
What?
Oh, 14.
Yes, sir. Over. What's z minus y?
2.
14 divided by 2.
Oh.
Don't worry, don't worry. Easy. 7. All right, someone else. Nobody else. In a minute, I'm just going to collect your papers, see how you did. Yes, ma'am. 40 what? 44. Let's try 44. Oh, yeah, this was kind of annoying, right? That's the formula for surface area. So you just have to plug them in. So L equals 5, W equals 8, and H equals 6. So surface area is 2 times 5 times 8 plus 2 times 5 times 6 plus 2 times 8 times 6. Do you agree with that? And now it's just, what are those numbers, right? 10, 80 plus 60 plus 96. Anybody else get that? And then if I add that 140, 240, 240 minus 4, 236. And area is centimeters squared. All right, somebody else. Yes, sir.
So I was looking to go around 45.
Let's see if I can help you with 45. So it's a formula, right? V equals 7 cubed.
Yes, 7 cubes. The cubes. But yes, I came with 340.
And you came up with the right answer.
Yes, though initially I doubted initially.
Nope. You don't no need to doubt. All right, 343 cubic centimeters. You measure volume with cubes. All right, somebody else, last chance. Anybody? All right, make sure your name's on it, please. I'm going to pause the video and edit out the beginning of class. Thank you. Give me an example.
Is this multiplication or addition?
It doesn't matter.
Okay, well, like 5 plus 7 plus 6 is the same as 6 plus 5 plus 7.
Yes, that's an example of community property because the order's messed up, right? But traditionally, we don't use 3. We just use what?
2.
We just use 2. And because we're in algebra, we're not using numbers. We're using what? Letters or variables. Thank you very much. So the best example, A plus B equals what? B plus A. They're simply telling you the order in which you add things does not matter. Does it work for multiplication?
Yeah.
Yes. So A times B equals B times A. Does it work for division? Very good. Thank you. No, it does not. All right. These are just basic definitions, guys. All right. So you just have to know these. All right. So let's talk about the associative property. Who remembers from last year the associative property? Tell me. Thank you.
B times A in parentheses times P is equal to B times A in parentheses times P.
Yeah, but if you don't mind, I'm going to put them in alphabetical order.
Okay.
All right. but that you are exactly correct. Now, he did the associative property of multiplication. Does it apply to addition? Yes. Does everybody understand that? Associative is how you're grouped, correct?
Yep.
Associative property is how you're grouped. A times B and then times C is the same as multiplying B, C, and then A. All right, hopefully everybody's agreeing with me on that. Oh, what was the additive identity? Oh, tell me. 1 plus 0 equals 1, but let's do algebra. So let's say instead of 1, this year we'll say what? X plus 0 equals X. That is in fact the additive identity. I try to tell kids, remember, identity is just remaining the same. So what's the, I put property here by accident. Everybody cross out property and make sure you put what?
Inverse.
Nope. Identity. The inverse is coming. The inverse is coming. So who can tell me what the tell me? Yes, X times 1 equals X. So multiplying by 1 always remains the same. All right, somebody else now jump in here. Additive inverse. Additive inverse. Now remember, inverse cancels out. Inverse cancels out. So if I'm going to cancel out A, what would I add to it? Yes, you're thinking multiplication. So it's A plus negative A equals what? 0. So that's the additive inverse. Inverses, you're canceling out. Identities, you're staying the same. All right, help me with the multiplicative inverse now, Nora. A times no, A times, not A times A over 1, but A times 1 over A, right? And A times 1 over A equals what? No, 1. There you go. You're dividing, right? Essentially, you're just dividing. All right, now remember, guys, I think this is easy. All right, if you're not sure about the properties, all right, we got to get them done. We got to get them memorized. All right, now the distributive property, of course, we've done this a lot. Does anybody remember the distributive? Tell me. Very good. Equals. No. Distribute AC plus BC. You with me? That's the distributive property. Distribute C to A and C to B. All right. And of course, the zero property. What is the zero property? Remember, Cappy? Tell us. Good for you, Matt.
A times 0 equals 0.
Yes, very good. Anytime you multiply by 0, you get what?
0.
You get 0. All right. So that's good. Most of you had a pretty good remembering of that. All right. Natural numbers. Who remembers what letter we abbreviated with? N. And what is the set of natural numbers?
1, 2, 3.
You're awesome, guys. Thank you for remembering. 1, 2, 3, ... Whole numbers we abbreviated with a what? I'm sorry, you're backwards.
This one. 0, 1, 2, 3.
Right, 0, 1, 2, ... But how do we abbreviate the whole number? Oh, almost. It was just W. Since he said Q, does anybody remember what Q was? Rational, you're right. Yeah, very smart, very smart. Okay, guys, thank you for remembering. Integers, I have no idea why they call it Z. Rationals, I had no idea why they called it Q. All right, and IR is irrational. Thank you very much. All right, now integers. All right, how do we write integers?
-1.
That's just a definition. What do you think whole means?
Like,
I honestly
like
don't.
zero is just like nothing. Not the big thing.
It's not a fraction. or
Zero, yeah. That's a good way of thinking about it. It's not a fraction or decimal. But again, I'm just telling you, these are just definitions. I have nothing to do with the explanation. What?
-1, -1, 0,
And then what?
1.
And then dot, 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 dot. So we say these are the whole numbers and their opposites, whole numbers and their opposites. Any decimals, any fractions here? No. All right, they're not. All right, now rational numbers. I can kind of give you a specific explanation or definition for that.
Any number that can be written for a fraction.
That is exactly correct. Rational number, any number that can be written as a fraction. All right, everybody needs to write that. Any number that can be written as a fraction. Any number that can be written as a fraction. So if it can't be written as a fraction, it must be called, yes, good job, guys. All right, so rational can be written as a fraction, irrational cannot be written as a fraction. So for irrationals, there were some specific examples I gave you. What is it a good example? Pi, thank you very much. Square root of 7, right? Now there was another famous Euler's number, which is the letter what? E. You will learn about that in Algebra 2. All right. Yes, that's after geometry. You'll learn about Euler's number. All right. E.
Oh, like I thought you meant the team noise.
No, it's EUL. All right. And it's 2.7186.
What about
42, I think.
what about that imaginary number?
Yeah, you're right. You'll learn imaginary numbers. Right now, we don't know anything about imaginary numbers. All numbers are what? All numbers are real. All numbers are real. So how do you write that symbol? One line, two lines, then make a big R. All right, that's the symbol for all real numbers. When you take Algebra 2, you will learn about imaginary numbers. And imaginary numbers split, right? That you have some numbers that are real, some numbers that are imaginary. All right, so I'm really proud of you guys for that. All right, hopefully you feel like you have a pretty good foundation for numbers. All right, and properties. All right, that's big. All right, so now we're just going to flip the page. I wrote down lots of examples. Lots of examples. Now, can you abbreviate? Yeah, I want you to abbreviate, guys. All right, I want you to abbreviate. What we're going to do is we're going to go down the row now. All right, we'll start over there with you, Sophia. All right, we're just going to go right down the page and just going to tell me what the property is. The quicker we move, the quicker we get it done. If you don't know, you can flip back and forth until you find it. There's specifically a lot of problems because I want you to know these. All right, number one. Right, so you can write COMM, and then I want you to put plus. Mr. Cappy, what are we doing on the next one?
Associative.
Associative. Be careful how you abbreviate associative. All right, don't get yourself in trouble writing bad names on my paper. Mikey, you're up. Number 3, what is that? Identity, that is correct. And that's multiplication. All right, next.
Identity.
Yes, that's an identity and it's addition. All right, next. The additive inverse, that is correct. Additive inverse. Next. Shh, she's got it. Yes, multiplicative inverse, right? Things are canceling out. It's an inverse. That's how I remembered it. Canceling out is an inverse. Staying the same as an identity. All right. Number 7, Ryan.
That would be distributed property.
Distributive property is good. Next. Yes, it is the distributive property. All right, he just checked out. So next, Aiden.
Well,
Yes,
multiplicative inverse.
you're correct. Multiplicative inverse. I'm happy. Max.
Additive identity.
Additive identity. Next,
Community.
you're awesome. Commutative property. All right, Nora. Right, associative property of multiplication. Next. Inverse, additive inverse. Told you this guy's supposed to be easy. Okay, back over to you, Sophia. Now, again, good job, associative, but we'll say what? Addition, right? All right, 15, Cappy.
Multiplicative.
You're awesome. Multiplicative inverse. Good job. All right, Mikey, 16. I tried to trick you and I got you. Yeah, you see why? I tried to trick you on this one, right? As soon as you see the order is mixed up, it's automatically what? Commutative, all right? And it would be addition. All right, next. Yep, zero property. All right, next. Nope, because you're not multiplying. They're canceling out. Do you agree? So if they cancel out, it's a what? You're correct. Additive inverse. Next. Perfect. And Ryan.
That would be that would be the community.
Is the order mixed up
Yes.
for number 420?
Actually, that would be.
That is correct. All right, here we go. Now we have to figure out where does 5 belong. All right. So what is 5? Everything but irrational. Perfect. And you remember, if I told you it's natural, it's everything down the line, right? Except it can't be irrational and rational. All right, that was very good. All right, Aiden, tell me about -9.
It's an integer, it's rational, it's real.
You're awesome. Max, tell me about -3.5.
Is it rational and real?
You're awesome, buddy. And then, oh, right on time, 24.
Okay,
What is it?
so I just check which one it is.
Yes. Irrational and what?
Real.
Irrational and real. Okay, you got a question?
Yeah, on 23, how come -3.5 can't be written as rational?
It is -7/2. That's why it's rational. It's not an integer, right? For integers, remember, they're only whole numbers and the counting numbers. Okay. Oh, this one's a tough one. Who's on this one? Do you remember? Repeated. Can repeated numbers be written as a fraction? So what if that's okay. What is 0.3 repeating? Do you remember? Anytime you have a repeated number, it can be written as a fraction, right? It would be, does anybody remember to tell me what 92 repeated would be? What number is it? 92 over, yay, thank you very much. 92 over 99. Yes, that's the fraction. So it's just rational and what? Real. I'm gonna save some time and I'm just gonna check reals for all of them, correct? All right, let's save ourselves some time. Okay, square root of 5. Nora. Irrational, good. All right, number 27. Rational and real. Uh-oh, I tried to trick you on this one, Sophia. Yeah, square root of 25. What is that? Yeah, it's definitely, say it again. What is the square root of 25? I tricked you. You see what I'm saying? So you immediately knew that was 5. So now it's what? Is 5 natural?
Oh, yeah.
You see what I'm saying, right? Shh, hold on. Sophia, are you good with that? So tell me what 5 is. Oh, 5 is the same as number 21. You agree? So it's just everything except irrational.
I understand that earlier when you said the last one, we should put the,
Oh, very nice. Because the example that I gave was not a perfect square.
the perfect square.
Yes, that's correct. That's correct. Okay, so now we're back over to Mikey, it looks like. Now, what do the 3 dots here mean?
It keeps going,
And it doesn't repeat. You with me?
irrational.
So it's irrational. Very nice. All right. -32.
Integer, rational,
Integer, rational, and real. Very nice. 0. You're awesome. All right. 0.198. You're awesome. Thank you. All right. 9. Go ahead. Ryan.
the natural whole, integer, rational, and by default, real.
Yes, thank you. Uh-oh, I tried to trick you on 34.
Well, it's 9.
Yes, there you go.
So it can just be-
Yeah, it's yeah. All right. You have to simplify if you can. You simplify if you can. Wow. You guys did great, right? Does everybody see? Easy. All right. So now I just gave you more examples. All right. So go back and finish this thing up. All right. And we're done. All right. Very good work for today, guys. And I'm going to look at your homework and give it back to you. Yes, everything. Yeah.
How much time do we have left?